Hey guys! So, Unit 2, Intro into Functions. Alright, linear functions. You should know what those are. So, linear, of course, means a line. So we're going to start out with our easy ones, the equations that come out to be, and graphs that come out to be lines. So, therefore, we need to review relations and functions first before we do that. So, this should be some review for you. Alright, let's start with a relation. Relation. It is a set of ordered pairs. It can be shown, typically written in a table, by a mapping diagram. These are a couple of ways to show them. Graphs, of course. Or expressed as an equation. So, relation. Sounds like relationship. Yeah, it's how two things are related to each other. Ordered pairs are, two items, x, y. Okay, the set of x values is called the domain. And the set of y values is called the range. You're like, oh yeah, I've heard of that before. Wow, why did my n go a little bit weird? Alright, sorry about that. A relation with distinct points is called discrete. So that's just like having dots on a graph, not connected. Let's see if there's any of them down here. Yes, like number 7. This is an example of a discrete graph. And then the next one we're doing is continuous. And of course this is a continuous graph because it connects, includes all of the points on this line, and here they're just random. So that is an example of each, discrete and continuous. It's what they sound like. Continuous just continues. It goes on. It's got those arrows on the ends. Yes. Let's see if I got some highlighter. If I can highlight anything. Relations. And we know ordered pairs, and we're about to, let's see what we're doing. Let's highlight domain. Let's highlight range. Let's highlight discrete and continuous. Why not? Those are pretty important. Alright, and then your definition of function, and then it's important to know how to identify if it's a function or not. So, a function is a relation in which each element of the domain is paired with exactly one and only one element of the range. Alright, here's an example of a function, and I'm going to give points. So 0, 1, -5, 2. So this is discrete to start out. Since these are all individual coordinates, this function is made up of only points. This is set notation, okay? So we have our brackets, and then the brackets, the set is contained of only these 4 points. Alright. This is a function because each of the domains, which are x's, is paired with exactly one y. So let's take a look. Now, just to show you, our x's are 0, -5, 6, and 5. So the good thing is they all start out different with different x's. So therefore, there's no way they can have multiple y's. And that's what we look for. We look for the same x to have different y's. The same x will have different y's if it's not a function. Okay, so an example of not a function. Again, I'm going to do 4 coordinates. Alright. Out of these coordinates, where's our mistake, or where is the deciding factor that we do not have a function? The same x will have different y's. Do we have the same x? Right here. We've got 6 and we've got 6, and they have different y's. So therefore those dots on the graph would be above and below each other. And that represents not a function. Also known as, when it's on a graph, as if they are above and below each other directly on the graph, that means they have failed the vertical line test. So I hope you remember that as well. Okay. All right. In order to be a function, the vertical line test must pass. So you drag your vertical line through your graph and it only intersects at one location at a time. Okay. So here, let's say that's my function. So it's clearly it's linear, it's a straight line. Let's see, do I have anything that can make a line for me? I don't know. Okay. Anyway, so we'll just have to do my cursor. So just imagine my cursor has this vertical line running through it. I'm taking my pencil, and that's probably what you were taught. Like, just take your pencil like this and drag it across the graph if you're looking at my camera. So imagine I have a vertical line. This vertical line, or I could just draw vertical lines to start with an example. If I keep drawing vertical lines, I will only intersect my original function one dot. So by dot I mean right, like here, here, here is where they intersect. They only intersect one place at a time. Okay. However, on my not a function graph, I'm going to draw a circle. And my vertical line test will look something like this. So this is, again, this is imaginary. You don't have to draw this. You don't have to draw the vertical lines if you don't want to. But now this is not a function. I start drawing a vertical line. I'm like, okay, right here, I'm going through one. If you remember in geometry, that's tangent. So I am intersecting one point at a time there. None over here, and that doesn't really matter, but it's inside the circle that is the issue. Right away, I come to intersection at the top and the bottom. So two intersections of one vertical line. So two intersections of a vertical line fails the vertical line test. So this automatically fails. This is not a function. Okay? Yeah, that's just the way it is. Sorry, circle. You are not a function. You're special, but you're just not a function. Okay. So with these, we're going to start practicing just listing domain and range. It's really important to understand domain and range, and also if it is a function or not. So let's start out, actually, yeah, we'll just do domain and range real quick. So with domain, you can just do these in set brackets, and then list your domain, which is your x's, range is your y's. So when you list these, do list them in increasing order, so smallest to largest. So my smallest x is -1. My next x is 0. Oh, they're already in order. Well, how fancy. 4 and 6. They will not always be in order. In fact, I would bet the y's are not. No, they are not. Alright, what's your smallest y? Your smallest y is -9. Your next biggest y is -5. And then -2. And then 3. Whoa, I started to do my bracket. Sorry, 3. Messed you up a little bit. Okay. Then, do all of my x's, are they individual, and do they have their own y's? Yes, there's no repeated x's, so this is a function because it passes the vertical line test. Alright, I will leave you to do number 2. Domain, or number 3, it's just a table. I mean, very similar to these. You shouldn't have trouble on that. So I'm going to let you practice. Let's look at the mapping ones. Okay, so yeah, let's look at one like 5 just to get you started. Every arrow is a relationship. So this is really a coordinate of -4, 0. So they just use this notation picture. So -4, 0, 2, 3. So this is 2 coordinates, 5, 7, and 5, 9. And then you just fill in domain and range like the previous ones. Okay, of course, this is where you literally do vertical line tests to decide function. However, with domain and range, they don't really list them for you. They don't list them for you. They don't even write out the coordinates for you, like they were so nice in the other ones. So you have to write out the coordinates for these points, okay? Yeah, I know, it takes a little bit of thinking, effort. Oh, you can do it. I know you can do it. Oh, and there is a point down here. So, get these 5, looks like, yeah, 5 coordinates for that one. Alright, let's see, okay, for this one I want you to think of, like, our interval notation for number 8. When we go, like, left to right for our domain, we are going left and right forever, aren't we? Yeah, this will continue this way, and this will continue this way. That means our left and right are going on forever. Kind of like when we did our number line, like our interval notation. So if I was going to represent this in interval notation, I'd say negative infinity to positive infinity, right? It goes forever that way or forever that way. Now on domain and range, you can pretty much do the same thing, except we will write this as all real numbers. Okay, so domain is left and right. Your range is up and down. So you have to ask yourself what's happening for my up and down, and what's happening for my left and right. So left and right is like before, the number line, but now you also have to include what's my up and down interval. Okay? Alright, and then decide if that's a function. So once you try that one, and then we'll see what we get. This one is similar to this one. And this one's similar to this one, I think. Well, let's look at the circle since we've kind of already done that. Think about this in interval note. Actually, yeah, we are going to do this in set notation. So we start, if we're doing left to right, so domain again is left to right, range is up and down. So if I start at the left, it's like when we did the number lines. Okay, we come over, we have nothing, 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 and then we finally have something here at -2. So we're going to start with -2. It's equal, it's all filled in, so we're going to do the equal bar, and then say that x is less than or equal to, because we know it stops somewhere, 1, 2, 3, 4, 5, it stops at 5, positive 5. So that's how I want you to write your domain. Go ahead and try the range on your own. You do it just like that, except it's up and down. So start, I see a little error maybe. So when you think about this, you want to go least to greatest, so you actually should be thinking down to up. So you want your lowest value, which, well, actually, let's do it. And lowest value on my y-axis is -2 as well. And then I'm going to put y in the middle, because range is my y's. And then my maximum is 1, 2, 3, 4. So clearly this is not a circle. It's something else. Special name. But we don't have to worry about that in this class. But it's not a pure circle. Since the diameter is not the same. Alright, so think about that as well. And I should go fix this. D. So you want to go down to up. That's how you want to figure out those relationships. Alright. Why don't you just stick with those and do 1 through 10. So finish those out. Well, not 1. We already did 1, 2 through 10. So pause the video and take your time and try to get these, because they're varying different pictures and givens and all that stuff. So try them on your own, pause the video, and then press play when you're ready. Hey, so you're ready to go over your solutions. Number 2 was no for a function. Number 3 was yes, and number 4 was yes. If you need to pause to read all these answers, I'm going to go ahead and scroll down. Number 5 was no. We had a 5 mapping to a 7 and a 9, so it's not a function. When the same x goes to 2 different y's, that's a no. No bueno. Number 6 was a yes. That one was all good. And number 7, that one was no. So here's my vertical line in yellow that failed the vertical line test because it intersected 2 points at the same time. And then double check here domain and range. Make sure you had these coordinates correct. Number 8. All right, number 8 was also the range. If you think about how far down it goes, it's going to go down and left at the same time. So down is forever and then up is forever. So that's all real numbers. And that is a function because it passes the vertical line test. And then we have number 9 where I left part of this out because I wanted to kind of do it with you. So function, this is no. Okay, so if I take a vertical line like right here, I'm intersecting 2 points at the same time, here and here. All right, now your range is your up and down, right? So that is all real numbers. It's going forever down, it's going forever up, but it is not going forever for my domain left and right. So if I start over here, I have nothing until I get to this number, which is -4. Is it -4? Yes. So we're starting at -4. Equal to -4, but it is continuing forever this way. This arrow goes forever to the right. This arrow goes forever to the right. Okay, so x is greater than or equal to -4, or you could have written that as -4 less than or equal to x. That would be the same thing. Then number 10, you just had to answer function, and that was no. All right, let's look at these graphs real quick. Alright, so why don't you pull up Desmos on your Chromebook and do this with me because it really helps to do it on your own so you are familiar with the buttons to push. So we're going to graph number 11. Alright, all we have to do is type in the equation exactly how it appears, which is y equals -x squared plus 3. Let's see how this negative stuff comes out. You have this keyboard down here to give you your exponents and fancy stuff. And that's a good thing because that's what you want to see happen when you have a negative in front of your first variable. You want it to go down. Then you have plus 3. So instead of trying to figure that out in your head or on graph paper or whatever, let's just put it in the calculator. And go ahead and get used to this calculator and how it works. So here we got this graph. It's called a parabola. And then we have to list domain and range and decide if it's a function. You can probably, let's start with function first. That's easy. Vertical line test. If I start running a vertical line all the way through, do we get any multiple points through the same vertical line? Nope. We're going to be good. So it's going to continue and spread out. We cannot intersect 2 points on a vertical line at the same time. So that answer is no. Or yes, sorry. It is a function because we don't get that. Alright, then domain. So domain is my left and right. So on my number line, I'm indicated. Now, they don't show the arrows on these, but you just have to remember that, yes, I do have arrows that show this as continuous down. So if I start on my left, what is the first thing I come to on my graph? And I mean on my graph. So my graph is actually all the way down here, so I can really start down here, and it's like, oh, that's an arrow. So if the first thing you run into, if that's an arrow, then you need to put infinity or all real numbers. Now we can put like infinity as far as the number line, infinity, negative infinity, positive infinity type thing. You can think about it like that. We're going to write it as set notation. So anyway, let's go ahead and keep that in our mind. So that's infinity because sometimes the other side will be different. And then we keep going. All right, keep following the graph. And what's it do on the right side? It also continues downward. But it's going right and down at the same time, so what we're concerned with is left and right. It's going left forever and right forever, okay? So that's infinity, negative infinity to positive infinity, so that's all real numbers. So we'll go ahead and I'll write that down before I forget. So domain is all real numbers. And by the way, another way to write that is this. It's this fancy R with like an extra line through it. That's another Excuse me. For all real numbers, my throat's dry. Alright, function we said already that yes, it passes the vertical line test. Alright, so let's now look at range, which is up and down. So again, I start negative and work my way up. So if I start down, what's the first thing I come to? Oh, I got arrows, right? Yeah, these are really arrows down here, and they keep going. So I have start with negative infinity, and then my graph keeps going and going and going. Oh, but it's going to stop. Look where it's going to stop. It's going to stop at 3. And then I don't have anything else up here. So I have to show that it stops at 3. It starts at negative infinity, and then it stops at 3. So if you wanted to write this in, think about this in interval notation, it looks like this. And then it doesn't have a hole, so you can put a bracket because it's equal to 3. But what we're going to write this right now is say that now range is your y's. We're going to say that y, how would I interpret this? Y is less than or equal to 3. And write it in set notation like that. Okay? Alright, hopefully that makes sense to you. I think you can do, yeah, why don't you try the next 3. Graph them in Desmos. Now, let me check this. If I say y equals something, let me make something up different from what you have. Y equals 4. Okay. Yeah, we're good. Yeah. So, you should be able to graph all those in Desmos. So go ahead and pause and then press play when you're ready to see the answers. Okay, your answers. Number 12, range, and function, yes, it's a function that passes the vertical line test. Number 13 was a horizontal line through -7, and it does pass the vertical line test. Domain, it does go forever left and forever right, but your range, you start at the bottom and come up. It will have nothing in the graph, will intersect any of the numbers below -7, and then anything above -7, it also did not include. So the only y value, which makes sense, if y equals -7, that's the only y value that could be in the range. So y equals -7, and probably should put that in. There we go. Number 14 was a vertical line. So if it's a vertical line, it definitely fails the vertical line test because there's an infinite number of points on that vertical line. So, no, range, so it does go forever down and forever up. So we're good on the range, all real numbers. But your left and right didn't work out. You come from the left, and you have nothing until you come to that number -1. So that number -1 was the only value of x's that were included, which again makes sense. Nothing above that, so x is just simply equal to -1. All right. Now, let's look at function notation. This, again, should be review. So with function notation, we are, instead of putting y equals, we are putting f of x equals. So y equals 2x plus 7, just written in function notation, would look like this. Where the input is what's going in the function. So here what's going in is anything here. That's my input. So that's my x's is the input. And the f of x is the output, or the y. It's the same thing. So you just simply can evaluate these. Like if you see that your function is 2x plus 7, and you have f of -3 is what you're trying to find. The -3 is in the place of x, so you just simply substitute it in and do 2 times -3 plus 7. 2 times -3 is -6 plus 7, and that is equal to 1. So, yeah, I'm sure you have done these before. Now, what we're going to have here on these examples is we've got 2 equations. So we've got the f of x equation, color, and then we've got the g of x equation. It's just 2 different equations, so you have to pay attention. When I have a g, I'm going to use pink function, And then when I have an F, I'm going to use my blue function. So feel free, of course, to use colors as well to help you with that. So let's see. I think you should be okay. You can really just put these in the calculator if you want to. You can. I would write them out first, you know. Let's look at number 5 and just do this combination one, f of 1. So what that means is you do the equation with a 1. Negative 5 times 1 minus 14. And then you do it again with the negative 4, but you want to subtract those answers. F of negative 4 is equal to negative 5 times negative 4 minus 14. And you solve those, and then at the very end, whatever answers you get, you subtract those two answers. Okay? Hopefully that makes sense to you. And then on this one, you're going to work inside out. So you start with your G of 12. So negative 12 squared again. Notice when I substitute in, I always put my x in parentheses. 9 times 12 minus 1. That's going to ensure that this answer comes out to be negative like it's supposed to. Negative 144 plus whatever 9 times 12 is. 108 minus 1. So 108 minus 1, and then minus 144 will give me negative 37. And then you have to go back and say, all right, that answer I have to times by 2. And then don't forget to include that. 2 times negative 37. And that should be, yes, negative 74. So your answers do result in numbers. They could be decimals or fractions as well. So why don't you go ahead and pause the video and go ahead and try these out on your own. Press play when you're ready to see the solutions. Just 1 through 6, or 1 through 5. All right, your solutions to number 1 is 31. Number 2 is negative 31 over 2, or negative 15.5. Number 3 is 2.44, or 61 over 25. Number 4 is negative 113. Number 5 resulted in this function negative 19 minus this function got positive 6. Negative minus a negative is really you're adding negatives and giving you negative 25. Alright, so we have some more, just throwing in some more fractions and absolute value. Just to show you, you can do these pretty quickly in the calculator. 1/2 minus 4/3 times x, and then I'm just saying, alright, my x is negative 9 over 16. So if I go to the calculator, 1/2 minus 4/3, and then I plug in my x, and it gives me the value pretty quickly. So 1.25. And that's the same thing as 5/4. So I think you should be okay on these. Why don't you go ahead and try those as well as, the next page. You can try those. You can try that. Alright, I guess 13. Yeah, let's just at least set this up. If f of x is equal to 34. So that is saying my answer, or my y, was 34. Now I got to go find x. So using this, what that means is I'm going to take 34 and plug it in here. So 34 equals, okay, I literally put 34, substitute it in place of my f of x, equals 3x plus 19. And then you, of course, just isolate x by subtract 19 to both sides, and then divide by 3. So go ahead and finish that one, and then also do number 14, okay? Oh, let's see. I think we're good on the, well, let's look at 15. I know you're like, word problems, yuckies. So Owen paid this landscaping company because he's lazy. He doesn't do his own landscaping. Look how much money you could save yourself if you just do your own. pay landscaping company $108 for initial lawn treatment and then $74 per month thereafter. Dang! The function P of T is equal to 108 plus 74T represents the total amount of money he will have paid after T months. So his initial plus this amount times every month. So finding P of 4. Oh yeah. So if you find P of 4, his T is after T months. So this represents his money spent after 24 months. And still finish this and go ahead and find P of 24. Okay. Alright. And then if he had paid a total of $2,994 to date, that would be a result of whatever some number is here. So this is your P of T. So you have to plug that in at the beginning as well, like the 13 and 14 up here. 2,994 will be equal to, and then put your equation. And then this time you're isolating T. So isolate T and see what that results to be. And then down here, we'll do those in the next set. So go ahead and do to 15B, starting at number 7. All right, pause the video and then press play when you are ready to see answers. All right, answers number 8, 9, and 10. Take a look. Number 11 and 12. Again, you can pause the video as you need to. If I'm scrolling a little bit too fast. 13 is 5. 14 is negative 27. 15A came out to be $1,884 for 2 years. That's how much money you would pay in landscaping. You could do that stuff yourself, by the way, and save about more than half of that money. Definitely more on landscaping. And then B came out to be 39. Alright, if you need to see any more work on those, just come see me in class or send me an email or see me during office hours. Yeah, on Wednesdays. So, number 16. Use f of x and g of x. So, let me go ahead and mark this in blue. And then I'll mark all of my f's in blue. And then my g's in pink. I kind of like that. It's like pink is for girl, or something like that. Okay, so you have a little bit more complicated stuff to plug in here. For example, what color am I in? Let's just go ahead and do this one. So that means I have to plug in c plus 2 wherever I have x. So c plus 2 will go here. Negative 4 times c plus 2 plus 9. So these are going to simplify out to be expressions, so not numbers. Negative 4c minus 8 plus 9, of course, combine like terms, and negative 8 plus 9 is plus 1. So that's your answer for that one. So not too bad. Your answers will just most likely have some variables in them. Let's look at, I guess we should go ahead and start. So you'll do this one, get this one, and then put minus in this one. Let's get this one started. Just because. So G 2m plus 1 will equal, oh yeah, so 2m plus 1 squared and then minus 5. So what's going to happen here is you're going to have to write this out twice. Okay, 2m, because like if this was just x squared, it's the same thing as x times x. So I have to do this times itself. So this is 2m plus 1 times 2m plus 1. You cannot distribute this. This is not allowed. That's illegal. Don't do that. So you write this out. If it's squared, it's times itself. So literally write it out like that, times itself. And then you have to do FOIL. Remember FOIL first. So 2m times 2m is 4m squared. Yep. And then plus times 1 plus 2m plus 2m. 1 times 1 is plus 1. And then minus 5. So simplify these two. One minus 5 is -4, so I've got that for my pink. And then I will do something very similar with the, or finish out the blue, do the F, and then I'm going to take all of this with parentheses and then put a minus in front of the other answer with parentheses, distribute that minus. So you want to, when you have that minus coming up here at the end, you want to distribute that minus through this F and then combine like terms after that. Okay. So just wanted to review that real quick. And I think you'll have to do something similar on number 19. All right. When in doubt, use the calculator to help you. I think the calculator can help you. So go ahead and try these out. And just up to number 20. And then press play when you are ready to see the results. Okay, here you go. So 17 was -28w plus 29. Number 18, I went ahead and showed the work plugged in. Just to remind you, when you square a monomial, you can square every single item, unlike the binomial. You can't do that. So this times itself would result in -4 times itself, which is +16. And then y cubed squared will allow you to multiply these. A product of a power, and that gives you 6. So you do multiply those. And when it's a monomial, a single term. Double term, write it out twice. Number 19 gave you a squared minus 6a plus 4. And number 20, here's your result. The blue function gave you -12m plus 36. So you put that here with your subtraction, and then that changes the signs to plus and minus. So giving you this result right here, 4m squared plus 16m minus 41. All right, that is only lesson 1, I know. Oh, we've got a little bit of longer stuff to do in this one, but it'll be good. So, see you on the next video.